Let's talk about solving a system of equations with three variables and three equations using the elimination method. There are lots of different ways that you can solve a system of equations, but elimination seems to be an easy way to go about this one. First, notice that I've labeled each of my equations, equation 1 and equation 2 and equation 3, so that they'll be easier for us to talk about. Now, when I look at this system of equations, the thing that makes me choose to do the elimination method to solve it is I notice this plus 1z back here on the back of equation 1. Having a 1 as a coefficient somewhere will make it easy for us to eliminate that variable from the other two equations by just creating opposites. So the fact that I've got a plus 1z right here makes me think it'll be easy for us to eliminate the 2z that is in equation 2 and the 3z that is in equation 3. I just want to multiply this positive 1z by something to create opposites in both cases. Now notice as we go along that we're going to use equation 1 to work on equations 2 and 3. Now let's see if we can get rid of the z that is in equation 2 first. What is opposite of 2z? Negative 2z would be. So let's take this first equation and let's create a minus 2z by multiplying everything here by negative 2. When I do that, negative 2 times everybody there gives me an equivalent equation over here, but now it's got a minus 2z like we wanted. Since these z's are opposite of each other, that means I can add these two rows together. Let's do minus 6x plus x. That gives me minus 5x. Here is minus 6y minus 3y gives me minus 9y. And 22 plus 2 gives me 24. Notice that in this new equation that we've created, there's now no longer a z. That was our goal. Let's call this new equation A and set it off to the side. We're going to need it in just a few minutes. Now, let's go back and see if we can get rid of the 3z that is in equation 3, again using equation 1 to create an opposite. What is opposite of 3z? Negative 3z. What would you do to this positive 1z to turn it into a minus 3z? You would multiply it by negative 3. So let's take all of equation number 1 and let's multiply it all by negative 3 so that we can create the opposite that we wanted to create. Negative 3 times everybody gives me this equivalent equation, but with a minus 3z back here like we wanted. Now let's add the two rows together, this multiple that we created with the original equation number 3. Adding them together, minus 9x plus 8x gives me negative x. Minus 9y minus 2y gives me minus 11y. And 33 minus 19 gives me 14. Here is a new equation B that has no z as part of it. Set it aside where you put new equation A. We're going to want those things in just a second. So at this point, we've created opposites of the z's in both equation 2 and equation 3 by using equation 1 in both cases. Now, let's just solve the system of equations that we've created with new equations A and B. Here they are again, new equation A and new equation B. If you wanted to solve this system of equations, it's only got two variables. So we can do this with the elimination method by creating opposites on one of the variables. Looks like it would be pretty easy to create an opposite here with the x's because of this being a negative 1 coefficient. It's easy to multiply -1 by something to get the opposite of what we have in the other equation. Now, opposite of minus 5x would be a positive 5x. How am I going to turn this negative 1x into a positive 5x? Let's multiply everything on this row by a -5, and that'll do it. So multiplying equation B by -5 here would give me a new multiple, but now with positive 5x at the front. -5 times everybody there gives us this equivalent equation. I've rewritten equation A right here, and now you can see that we've got opposites on the x's. Once we have those opposites, let's add together the lines. The x's eliminate like we expected. 55 minus 9y gives me 46y. -70 plus 24 gives me -46. So now I've got a little equation that is easy for us to solve. 46y equals -46. If you divide both sides by 46, y is -1. Once you know what y is going to be, you can go back to equation B and figure out what x is going to be. Here is our equation B. We now know that y is -1, so let's put it in for y everywhere we see a y, and then let's do the arithmetic that results. -11 times -1 made positive 11. If I subtract 11 from both sides, 14 minus 11 gives me 3. But now I don't want -x equals 3 for an answer. I want to solve that for positive x. Divide everything by -1, and we get x is -3. So at this point, I know that y is -1. I know that x is -3. Once I know those two variables, we can go to any of the original three equations and figure out what z is going to be. I chose equation 2 because it had the smallest numbers and looked like the easiest arithmetic. Let's take -3 and put it in for the x that we see. Let's take -1 and put it in for the y that we see, and then let's do the arithmetic that results. Bring down the -3, and multiplying -3 times -1 made positive 3. Bring down the 2x and the equals 2. Now, -3 plus 3, those are going to go away. So I'm left with 2z is equal to 2. If you divide both sides by 2, then z is going to equal 1. Now, I need to write my solution as an ordered triplet. The x is first, the y is second, and the z is last. So x was -3, y was -1, and z was positive 1. Here is our solution. An ordered triplet has parentheses around it, commas between the x, the y, and the z, and this solution should work in any of the three equations. You can substitute those numbers in for x, y, and z in any of the three equations, and you should now have a true statement. The key to solving by elimination is create opposites. You can easily create an opposite when you've got a 1 coefficient. Use whichever equation has that 1 coefficient to help you get started on the other two equations.